So let's start with the Dockerfile for the server. We'll use this Alpine image, which has a Go runtime pre-installed on it as a builder image. So inside our builder image, we'll switch to this workspace working directory. Then we'll copy the files that we need to build the binary here. Then we are going to download the dependencies and build our binary. Then we'll create a server image and use our build artifacts from the builder image. And also we pick a non-root user for security reasons. Then we are going to set /main as our entry point, which is a link to a binary that we just copied from this builder image to this server image. And that's it, I guess. This is our Dockerfile for the sake of completeness. I'll copy all of this and paste it into the Docker file inside this client folder as well. Then rename the container name as greeter client instead of greeter server for some consistency. And that's the only change I need actually for the client's Docker file. So I'll save and exit. Then we'll modify the build script to build a container image and push it to our local Docker registry. So we build our image with this label and then push it to our local registry like this. I'll also copy this guard clause here so that if the process fails at any of these steps, we can exit without proceeding with the rest of the build process. So just one thing, this is the server image, not the client image. So I'll change this as greeter server. And that's all we need, I guess. Let's save it and quit the editor. Then I'll copy this file's contents and paste it into the client's build script and rename the labels from greeter server to greeter client, and our client build script is good to go as well. Let's build the client and server by running hack build sh in each of these projects respectively. And now that we have the container images that we built, we can create some containers and put them into pods, shall we? For that, we'll create an infra folder in each of the project and create a deployment YAML file for client and the server. So let's start with the greeter server YAML. Greeter server will be a Kubernetes deployment. It will have a name greeter server and it will have a label app greeter server. Our deployment will have a single replica and the pod that this deployment creates will have a single label named app greeter server as well. And we'll have a single container inside that pod, and the container image is the image we just built and uploaded to our local registry. We'll also pass this ADDR argument to our application to let it serve incoming requests at this port from any interface. And as far as deployments go, that's all that we need, but I'll add two to-do remarks here because when we roll out SPIRE, we'll need to mount SPIRE agent's Unix domain socket from a volume to this container so that our pods can get their SWITs and other security bundles from the SPIRE agent. The service in front of the greeter server will be of type load balancer, which means it will have a network route that others can reach from outside of the cluster. And finally, we'll expose TCP port 8123 as the port of our load balancer service. And that's it, I guess, for the server part. Let's apply the manifest with kubectl apply-f and see what we get. And yay, we have a server, and it looks like it's serving on its local interface, which is good. Or is it? It's not so good because localhost is a local interface to the pod, so binding it will cause a routing problem from the client to this pod, but I'll pretend that I haven't seen it and fix it when we actually observe this connectivity issue and try to debug it a little bit. But other than that, the server pod looks up and running, which is good. And in the next video, we'll do the same for the client application, so see you there.